Hi everyone, I'm Dylan Connolly,
And I'm Josh Frechette.
and we're going to be talking to you about Clio, the open source toolkit we've made for the creation of digital pop-up exhibits, interactives, and so much more. So what is Clio? Clio is an open source toolkit. Open source just means it's got an open license, it's available on the internet for free, for anybody to use, for any purpose at all. We've specifically designed this for the creation of digital interactives, meaning just kind of any situation in a museum where you would need some sort of media interactive to convey some further context to physical objects. We've designed this toolkit to be accessible to anybody with either photo editing or web design experience. We've made 13 customizable activity sets to use for different programming and audiences, and those templates are fully customizable and replicable. We've also included hardware designs for a kiosk specifically designed to be used in a pop-up kind of context. Everything is designed in HTML and JavaScript because those are the two most commonly known coding languages according to the Stack Developer Survey. And so people in a museum are more likely to know HTML or JavaScript than any other programming language on the planet. And we wanted to do that because we wanted to really, the whole goal with this project was to lower the knowledge buy-in for current museum professionals on integrating open source technologies into their programming. So the open source technologies that are in the toolkit are kind of divided into two halves. We have the physical half, which is for the kiosk, which is hardware and software designed to run on a Raspberry Pi computer and be in a kiosk that's all 3D printed, as well as the hardware-independent graphical user interface that includes the interface for setting up the kiosk, as well as the activities themselves. We've printed everything using a pretty cheap consumer 3D printer, a Creality CR10 Mini. Only costs about a couple $100, so it's really a tool that can be picked up by a lot of institutions without a huge financial buy-in. We've also included specifications for hardware. It's designed to run on a single board computer. We've used a Raspberry Pi 4 and a Raspberry Pi 3B+, but you can do this with any single board computer capable of running a Linux distribution. Every piece of hardware we're using is community driven, from the 3D printer to the Raspberry Pi. Everything is designed to be community oriented and open source, or as close to open source as you possibly can make something. The software we're using is also open source. We're using the Debian distribution of Linux, the Apache web server software, and the Chromium browser. So some of the activities we've designed for this project, one of the first one we came up with was a image comparison. We thought, what's more tactile than moving a cursor and really seeing what the difference is between two things? I think that's a really good way of providing context in museum educational programming. So we've superimposed two images on each other, and you can drag the cursor over. And then there are also highlightable tooltips and hot areas. The toolkit has instructions on how to customize these images. You can put those tooltips anywhere using some XY coordinates on your image, so it doesn't need to be where we've set up the template. You can have and highlight any kind of features you want in between the two images. So as you can see, this image in this activity, we've compared a Chinook salmon to a sockeye salmon and highlighted those anatomical differences between the two. The tooltips can also be programmed to have informational pop-ups, so you can provide even more context for what those differences mean between those two images. One of the other activities types we've designed is a tile match activity. It's basically your basic kind of card matching game. We've got 4 tiles on the left side, 4 tiles on the right side, and those are the titles, information contained in the cards, and the images are all customizable as well. You can also rearrange these in any order you like. You can also customize the correct and incorrect responses prompts, so you can really customize this as much as you want to. We also have a slideshow activity we've designed with main slides and basement slides. So you have vertical and horizontal movement within the slideshow. You can keep adding basement slides to further contextualize whatever that main slide is you're trying to achieve. It's also, you have the ability to toggle an overview of the entire slideshow. We've also created an ability to combine activities into an activity we're calling a meta activity. So say you wanted to create some image slidovers, a video playback, and a 3D render of a particular object in your collection. You can combine those all into a single activity that contextualizes a physical object or is a program in and of itself that you're running as part of your educational programming. The sub-activities load within the meta activity, and you can contextualize those activities, like I said, like combining them into different ways. The hardware we've designed is designed to be portable, modular, and heavy duty. It's designed to hold up to kids. The program we're designing this for, the Burkemobile program at the Burke Museum of Natural History and Culture, where we're pilot testing this, goes to a lot of schools with kids as young as 5 or 6. So we want to make sure that there were included plans for the kiosks that were kid-proof. So we have a padded screen projector that's printed out of a soft filament, as well as the harder elements of the kiosk, which are the hinge, the case, and the modular attachment part, which can either be a C-clamp or a stand you can put onto a table. We've also are including plans to suction cup to a solid surface. Everything is 3D printed using really, really widely available and inexpensive filaments. All the filaments we're using are about $20 a spool, and you can print multiple kiosks with a single spool of both of these types of filaments. And like I said earlier, all the electronics we're using are kind of community-oriented technologies. They're off the shelf. There's nothing that's required to be soldering. These are all supposed to be introductory level electronics that are designed to teach people about computing and coding. So we've been pilot testing the project at the Burke Museum of Natural History and Culture in Seattle, specifically within the Burkemobile Mini Museum pop-up educational program. It is a program that goes to schools outside of King County and sets up a mini museum at community centers, school cafeterias, any place that you might want to set up a mini museum for people that can't make it to the Burke proper in Seattle, but want to access the state museum's resources throughout the state of Washington. In particular, we're deploying this in a mini museum about nature's networks, about interconnected ecological networks, hence why we've been showing some examples of salmon-related things. Our project was funded for very little money. We got a seed grant from the University of Washington Resilience Lab for about $1,700, and that's provided most of our material cost, including the printer, the filaments, which we've gone through a lot of for pilot testing and prototyping, as well as all of the electronics we've used to build multiple kiosks. And our work has been supported by the UW Museology Graduate Program paid internship pilot. That program is fantastic because it supports student-run research and research-oriented projects. So without those two things, this project would have never come together. We're also evaluating the project using the MuseTech evaluation model, which is a framework for evaluating museum technology projects that was published last year. So what's the future of Clio? We are all about accessibility. We've included accessibility options in our kiosk interface. We have things like the ability to change contrast modes, we have dyslexic friendly fonts that you're able to switch to within the kiosk. You can also add captions to things. The whole idea is that we are making this project as accessible as possible to as many people, both from a development standpoint for museum professionals making this technology and the end visitor, the user of the museum visitor, to have as many accessibility options as possible. We also want to encourage more technology professional development in the museum field. There's a lack of professional development overall in the museum field, and we really wanted to embrace the opportunity to provide museum professionals with some simple tools so they can start exploring integrating technology in their day-to-day work, even if they're not a, quote, tech person. We also want to start fostering an online community of museum professionals working with this kind of technology. On our website, cliomuseums.org, we're going to be setting up a series of instructional blog posts showing you how to use Clio and how to integrate all of the activities we've designed into whatever kind of programming you want to make with Clio, as well as starting a forum that will be hosted on cliomuseums.org for museum professionals to share their ideas of different projects they've done using Clio, ask for bug fixes, anything you would use a forum for to provide some support for the overall community we're trying to build. We also have several long-term goals. We want to create more activities for Clio as we get more funding and more opportunity to work on this project. And we want to explore, especially in a time where so many museums are looking for digital strategies right now because of the COVID-19 outbreak. We are currently exploring ways we can take some of these activities like the image slide-overs, video playbacks, and integrate that into a purely digital context, creating digital exhibits and using those same activities so you can create these activities, deploy them on your website, in a museum gallery, and in an educational program by just creating a single activity that you can use over multiple types of programming. Well, I want to thank you all so much for paying attention, and we hope you enjoy the rest of the conference.